Ok, boa tarde a todos. Eu gostaria de dizer que vocês são todos muito bem-vindos à nossa NF Terça, nosso segundo dia de semana de comunicação e multimeios. Temos aqui, na nossa mesa, Tiago Domício, meu colega de organização, professora Jane Almeida e o professor Brett Stalbaum, da Universidade da Califórnia de San Diego. E a gente vai falar um pouco sobre NFT hoje, fazer uma pequena introdução, o que são e por que eles são tão importantes, porque é um assunto tão atual hoje em dia. E eu vou passar essa bola para a Jane.
Oi, pessoal. Boa tarde para todo mundo. É um enorme prazer estar aqui hoje com vocês e ter esse convidado super especial, que é o professor Brett Stalbaum, da Universidade da Califórnia de San Diego. Brett é um amigo, parceiro de pesquisa, já esteve na PUC várias vezes. O Brett tem mestrado em Belas Artes pelo Laboratório de Mídia Digital CADRE da San Jose State University, e ele tem um bacharelado em estudos de cinema pela San Francisco State University. Ele já ensinou também na San Jose State University, e ele foi também professor de informação no Evergreen Valley College durante algum tempo. E lá ele se especializou também no ensino de linguagens de programação, por meio também de educação à distância na web. Ele hoje é professor do curso de graduação, né, que é o que se chama undergraduate nos Estados Unidos, de computação interdisciplinar nas artes, chama ICANN, na UCSD. Né, e ele fez pesquisa sobre Big Data, sistemas de informação geográfica nas artes e mídia locativa. Então, com mídia locativa foi a parte que ele esteve no Brasil, que ele trabalhou com vários parceiros, inclusive com Marcos Bastos, o coordenador do nosso curso. Ele participou aqui do CADRE, do Instituto, e publicou também artigos, e ele tem vários artigos que são publicados aqui no Brasil. A própria professora Lúcia Leão, que vocês conhecem bem, já publicou coletâneas com artigos do Brett. Brett e eu temos uma parceria já de muitos anos. A gente fez exposições juntos na Universidade da Califórnia, workshops. O Brett vem ao Brasil também fazer workshops conosco, e eu poderia dizer que é um enorme prazer. A ideia de chamar Brett Stalbaum para essa mesa foi justamente porque ele me convidou para uma abertura de sua aula na UCSD sobre NFT, onde esse assunto foi ali debatido com os alunos dele na abertura do semestre dele no início desse ano, né? Então, acho que ele tem muito aqui a nos contribuir com este debate, né, com essa conversa aqui entre nós. O Brett vai falar em inglês. A gente tem uma apresentação dele, um PowerPoint que ele fez em inglês, que foi traduzida para o português, né? E ao final, por favor, se alguém tiver dúvida, vai colocando aqui que eu vou escrevendo e eu passo para ele para a gente aí contribuir com o debate, tá? Então, a gente vai começar com a fala do Brett. Brett, could you understand anything?
Some of it, yeah. My ears do hear Portuguese a little. So yeah, thank you very much. Thank you for the nice introduction. I guess I should start now.
Yes.
Okay. Well, first, I just want to say it's I'm honored to be here. It's really nice to be back at PUC. First time I came to Sao Paulo, I think, was 2005, and we did a workshop at PUC. So it was the first place that I presented in Brazil. So it's really, really nice to be back. It brings back some really, really nice memories of your campus and your students. I was there with a group called C5, and we did some locative media workshop activity way back in 2005, like going to random GPS places in Sao Paulo, and it was a lot of fun. So I'm really, really pleased to be back. I'm also, super pleased to be here with my dear friends, Professor Jane Almeida and Professor Bastos. Very, very nice to be back with you. And I'm just super pleased to be here. So I was invited to speak about NFTs, non-fungible tokens. And I think, the reason I was invited is because I was I was teaching a class last year, and Professor Jane Almeida was a guest in that class, and who else was there? Cicero Silva was there, and we had a good talk about non-fungible tokens with the class, but from a perspective of current events, new things happening in the art world, and I want to be transparent about that. Is that my expertise, what I teach, what I research, what I study is really not non-fungible tokens, blockchain, or crypto. I don't. These are not things that I do. I have some thoughts about them. I know a lot about them, but I'm not an expert. I'm speaking to you from the position of a studio artist who has been thinking about these for a long time. One of the classes that I teach is a large history of computer art and the history of computing in the arts at UC San Diego, where we talk about the important range of the field, which ranges, I'll talk a little bit about it later, but all of the very different kinds of things that artists do with computation that doesn't involve making pictures. Making a picture with a computer might be a starting point for many artists who are working with computation, but it's also kind of a well-tread path in computing. What many people are doing with non-fungible tokens is, in fact, I'm going to make the case today. This is going to be part of my my final conclusion, is that there's really nothing new going on with the artists who are creating non-fungible tokens, or maybe a little bit new and some things that are exciting about the near future, but that we're at a point where the kind of art that's being minted and then entered into a system of exchange via this non-fungible token mechanism in the blockchain is actually sort of a repeat of history, and so far not a very interesting one. Not that it can't go interesting places. I have my optimism as well. A little more background. I was part of a generation of artists who, in the 1990s, who were the first artists to think about what the internet meant to us in terms of medium specificity. That the internet was a particular kind of thing. And that was our orientation in the 1990s, is that this is not just a place to post your pictures of your art. It's something different. It's a medium with specific properties that, that through the strategies of artists throughout history, and a lot of strategies being drawn from very contemporary art at the time, a lot of ideas about conceptual art could be explored as a specific medium, and not as a place to show images. The internet is not a slideshow. The internet is a computing environment, and the interesting work for us was going to be what happened in that computing environment. So you'll see that theme quite a bit throughout this. I should also, just to be transparent, I'm a long-time opponent of Bitcoin, which was the first cryptocurrency. So I'll talk a little bit more about that. But my main objection has been, as a green, my main objection has been against these proof of work algorithms that use a lot of electricity. So some of the NFT minting that's taking place today, and we'll go into some of the technical details, or at least to reference them, is very, very computationally expensive and wasteful of electricity, which pollutes the planet, contributes to global warming. There are some very, very big problems with it. Yet I'm also, supportive of many of these crypto projects. In fact, some of the problem of wasted electricity is being solved. That's very good. So let's just go ahead and play this all out. My second slide. So these are roughly some of the ways that we're going to look at NFTs today. We're going to look at the technology. We're going to look at the history of some of these technologies. We're going to talk about how crypto is kind of a term that occludes what they really, what the technology really is. The technology that we call cryptos, cryptocurrency, that is the foundation for non-fungible tokens, is based on a lot more than cryptography. So we'll get into that and try to understand that a little better. We'll go through some of the economics, some of the history, some of the ideology, a little bit of the ideology behind the original notion of a cryptocurrency, talk about NFTs, kind of computer art, and talk about this idea that I've already introduced, medium specificity, and placing that as sort of a central concern over using the internet as a slideshow, or now the internet as a place where images become kind of like tradable artifacts. That's the case that I'm gonna make, at least. So next slide. First, there was Bitcoin. And this is not true. There's actually a deeper and more interesting history of technologies that contribute to the possibility for cryptocurrencies and ultimately NFTs. And I want to go through some of those today. So, the crypto wave does not start with Bitcoin. There are a lot of sort of technologies that came together and had to be creatively assembled, and a very creative act of assembly, but creatively assembled and put together to make things like Bitcoin possible. And one of these is distributed computing. This is one of the things that I teach in some of the more technical classes that I teach at UC San Diego, is kind of, honestly, more traditional forms of distributed computing. But to hang a little bit of a rough definition on this, distributed computing is you all use distributed computing. It's using more than one computer to process data and do work. What's happened with Moore's law, and how we keep Moore's law producing CPUs that are capable of producing or processing the amount of data that we face today, has been through the addition of multi-core CPUs. In other words, having, instead of just one central processing unit, now we have 4 or 8 or 16 cores on the main CPUs in our computers that do the processing. So that's how we're able to, scale up the capacity of processing, is really by adding more computers to a single CPU on a personal computer. Well, the kind of, I teach a kind of supercomputing that's very, very common in scientific computing. We use it for art purposes, but it's much more kind of normative for scientific computer that uses thousands of computers to process large data. So one of the things I teach students is this kind of distributed computation that uses, not just multiple cores on a CPU, but it uses, hundreds of computers. At San Diego Supercomputing Center, we have, computers that you can run a computation job that uses 60,000, 60,000 cores, 60,000 different computers to do it. So distributed computation is an old idea, and a very, very important idea that ultimately contributes to a lot of the ideas of crypto in a different way than kind of traditional Beowulf, MPI type programming, which is something that I do teach. So a lot of these technologies are quite old. The first internet packets were sent on the ARPANET in 1969. Networks are really the fundamental enabling technology behind cryptocurrencies and NFTs, of course. So the kinds of networks we're using are really old. The protocols that we still use on the internet today were invented in the early 1970s. That's the Internet Protocol and TCP/IP, which is Transmission Control Protocol over Internet. Vinton Cerf and Robert Kahn developed these in the early 1970s. When I was a young person, 1989, Tim Berners-Lee, this is when the World Wide Web, which is it's really a protocol on the internet. The internet exists a long time doing different things before the World Wide Web or web pages exist, but that comes about in 1989. And these are all examples of distributed computation. In other words, the World Wide Web itself is a network of HTTP computers, computers that do HTTP work. They have a server, an HTTP server, and they're linked up to each other in different ways than what we'll find cryptocurrency uses. But nevertheless, it's a network of computers. And I guess this is going to be a big technical point that I make over and over again today, is that really a cryptocurrency or NFTs are enabled by networks of computers. And these networks of computers are all participating in something, such as Bitcoin is the first example. They all participate in a protocol that enables the production and distribution and verification, the cryptological verification of cryptocurrencies. And that is so there is a Bitcoin network of computers that do Bitcoin stuff. It's hundreds of thousands of machines that do this, and even more people that connect to those via the wallet, via the idea of a wallet that we'll get into. So network is really the basis. It's really the basic fundamental ontology of NFTs, the basic fundamental ontology of cryptocurrencies. Okay, so I'm on to my next slide. So distributed, what is the distributed part in blockchain and the blockchain data structure? The three major elements of these kinds of technologies are this data structure called the blockchain. There's a verification process that involves the cryptography. And that's all shared between this network of computers that verify in a transparent, secure, and audible way the transactions that are added to this sort of internet ledger called a blockchain. And it's a really key thing with cryptocurrencies. If you're running the software that produces and manages cryptocurrency and does the verification of transactions, you're also, the other thing that's distributed around the internet is the data structure itself. The blockchain is the storage location of every transaction that has ever happened. So if you're, for example, mining Bitcoin, you have a copy of the entire blockchain, the entire history of the network that's downloaded to your computer. And that's the distribution. And this is really the secret sauce, actually, of, cryptography is very important, but kind of even more important is the fact that the ledger is spread around so that everybody can verify, so that computers can work on the problem of verifying that transactions that take place are legitimate transactions. I guess the metaphor might be your bank. When you put money in your bank, right, through an online transaction, your bank is the trusted entity. You trust that the bank will take your, 1,000 reais and put it into your account with your name. And when you take money out, you trust that they will agree that you took out a certain amount of money, right? So the agent of trust really is that institution. Well, the idea with all of the kind of blockchain technology is that agent of trust becomes distributed around all of the participants in the network, that everybody can look at the ledger, everybody can look at the records, and therefore, and also using cryptographic algorithms, confirm the truth of any transaction that takes place there. And for Bitcoin, the original, cryptocurrency, the secure way that all of these different computers that are participating in verifying transactions do that work is something called a proof of work algorithm. And, proof of work algorithms are very expensive. They require a lot of power, a lot of electricity. What they're really doing is they're doing their best to guess at the answers to some cryptography problems. And if they guess right, that winning node on the network gets to add to the blockchain, and to sign the blockchain with its private key and its private key, and then people are able to, through its public key, verify that that transaction was indeed approved by, sort of a concurrence of the entire network of computers looking at that same blockchain and thinking about those same transactions. And that's sort of the basic technology that we're talking about here. So, proof of work is expensive, and I'll come back to that. Let's look at a little of the history, though. Here's a really important piece of software in the history of distributed computation called SETI at Home. It's also called BOINC, which is the kind of more generic software for doing this kind of distributed computation. Of course, I'm very proud of this. This is I teach for the University of California. This is an historically important and presently important project from the University of California at Berkeley. It starts in 1999, and it starts out as SETI at Home. And what SETI is it's an organization that searches for extraterrestrial intelligence. It's looking for ET, looking for signs of other life forms in the universe. It's an astronomy project, mostly radio telescopes that collect data. And then we need kinds of computation to verify that, to kind of look for signs in the vast amount of data we collect of extraterrestrial intelligence and basically radio signals. And they were able to collect. This is a really, really good example, even from the 1990s, of what's called the big data problem. We are able to collect more data with our sensor networks than we are able to process the data. So, an awful lot of data science is very interesting because we have to be very smart about our resources in terms of processing data. And the most constrained resources are actually the actual computation. It's CPU, it's the processing units that have fallen behind the data. There's more data than we can process. So SETI had a problem, and working with UC Berkeley, where a lot of the SETI astronomers are, it's an international kind of project, they developed a piece of software that people could download at home, and it would run as a screensaver. I know I should explain what a screensaver is now, because it's largely an artifact of the past. I'll pass over that. You can look it up in case you're a young person and you don't know what a screensaver is for. But, it was basically when your computer had idle time, your personal computer, SETI at Home would turn on and start to use your computer's computing resources to process some of this data that it had downloaded from SETI and send the data back up to SETI. And one of the really interesting aspects of this project, to search for extraterrestrial intelligence, was that, people wanted to get credit for, to see how much computation they were contributing. It was sort of a contest to see who could do the most SETI computation. And so SETI built into the software a way to account for how much computer time people were contributing to the project. So then that's what BOINC does. It actually uses internally something called cobblestones, which is, this is my point, a kind of currency, a kind of cryptocurrency, because there was the use of public and private keys and all of this as well. Cobblestones were a kind of currency through which people were awarded just credit, like a leaderboard on a video game, who was doing the most. And it was built into this software. It wasn't a fungible medium of exchange by any means. You couldn't trade your cobblestones with other people. But, this idea of these kinds of digital stores of values as credit have been built into software for a very, very long time. It's actually a very, very old idea. And it is an idea, largely, of course, it's only possible via distributed computation of various kinds. So here's a moment in that important moment in the history, honestly, of distributed computation. Next, very, very important as well as Napster and BitTorrent. I don't know if any of you have ever used BitTorrent. Probably, I would guess. But my point in bringing these up is it's not only encryption that's important, or distributed computing even. It's a specific kind of distributed computing that enables cryptocurrency, and that is peer-to-peer computing, where, in something like Bionic with SETI at home, there's still a central computer, and there are client computers that are doing the processing and sending things back to a central place. Well, peer-to-peer computing is a different model of computing that first became very, very famous in 1999. Sean Fanning and Sean Parker made a piece of software called Napster that let people share their music. The music industry didn't like this. That's a whole kind of amazing story that you could look up. Another programmer, Bram Cohen, liked what they were doing, but and created something that was for more generically for sharing any files, movies, music, programs, anything, that could go in this network. And there's no center to this network. It's all of the individual clients able to talk to each other and maintain and repair the network as clients come and go to maintain files and share files, across the internet in a way that really can't be interfered with by removing the central server. So peer-to-peer is a very, very important kind of technology and peer-to-peer technology is the basis. Peer-to-peer computing really is the basis of all cryptocurrencies and NFTs. So just technologically, it's important to understand that. By the way, Bram Cohen, who invented BitTorrent, has a cryptocurrency project right now called Chia.net, which is a quote-unquote green cryptocurrency that uses something, I'll talk about it later, that uses something different from proof of work in order to verify its transactions. It uses something called proof of space and time. It's not very important, but it's just the key thing is that one of the inventors of the people that really helped popularize peer-to-peer distributed computing on the internet also has a cryptocurrency project today. That is not an accident. That's completely natural because cryptocurrencies are based on peer-to-peer computing. And here's one of the all-stars of peer-to-peer computing with a crypto project. Okay, on to the next next slide. Cryptography itself is quite old. It's much older than Bitcoin. Obviously not a new thing. It relates a little bit to history here. It's there's some interesting histories here to think about in this context. Between the 1970s and 1989, really into really later, 1992, 1993, the internet was largely controlled by the military and universities. And if you were on the internet, you were military, government, or university, primarily tier 1 research university. Those were the users of the internet. In other words, pretty small number of users relative to today. Cryptography was still very important. It was developed, kind of the private and public key cryptography that is the dominant way that we do cryptography today, and is the way that we do cryptography for cryptocurrencies. Was originally published and discovered in 1976, but these concepts become much more important after 1991. Phil Zimmermann, I think people forget this a little bit, but Phil Zimmermann's very important. He developed a piece of software called Pretty Good Privacy, PGP, back in 1991. This was the dawn of the World Wide Web. This was kind of the dawn of that moment when lots of regular citizens started to use the internet. This is when you could start to have the internet not at work at your university, but at your home, access to the internet. I first got onto the internet in 1993 was my first time using the internet from my house instead of from my university. So, this is the dawn of when the internet starts to become very, very popular, starts to become part of sort of public culture, starts to become part of the public discourse and the news discourse and cultural discourse, is really the early 1990s. And it was in the early 1990s that people began to realize the need for good privacy. So this was actually, Phil Zimmerman's project, Pretty Good Privacy, was actually kind of a radical project at the time. The United States government was suing him. There were legal things. The government didn't want people to be able to encrypt their data. The United States lost that battle. And Pretty Good Privacy could be used using a public key, private key cryptography system to also, encrypt anything. You could encrypt email, but you could also encrypt your hard drive with it. And so this is really, really important. So by 1991, in 1991, most of the elements for cryptography, most of the elements for a cryptocurrency kind of existed. It was really the development of peer-to-peer networking in the late 1990s and early 2000s that sort of finished all of the technical elements that, the basic technical elements that were necessary to put together in order to have things like cryptocurrency. So here's the bigger point, right? Cryptocurrency, these kinds, and NFTs are based on the network. They're based on 1970s TCP/IP, still dependent on that because peer-to-peer networks run on top of TCP/IP. It's distributed, it's a cryptocurrency is a case of distributed compute, and really specifically it's peer-to-peer distributed computing. And I think this is important because I think we call it crypto and we talk about crypto. We use the term crypto to talk about this entire field of human endeavor and computer science endeavor, but it really is these other technologies as well. So the word crypto kind of hides from us some of the other important technical aspects of the medium, because it is a medium, and hides some of this other stuff so that it's not foreground, and thought of as being really part of the ontology or the nature of cryptocurrencies. We could call it P2P coin instead of crypto coin. We could call it, P2P currencies instead of cryptocurrencies. And these would be equally good, if not completely better names for these endeavors. Okay, so let's jump up to 2009. Let's go to the next slide here. Satoshi Nakamoto, 2009, invents and introduces Bitcoin to the public. You can look up the legends of Nakamoto if you wish. It's still, not truly known if it's an individual person or if it's a reference to a collective of people. And you can look into that. It's fascinating. It's quite a romantic story on the internet, I think. Really, really a fun history. I encourage you all to go look at it. I'm not going to talk about it much today. But at very least, we know it was a collective of programmers who created Bitcoin. And they put all these kinds of technologies that I've already talked about together, and used cryptography and file sharing to create this new idea, sort of a cryptocurrency. You can hear my cat over there.
Your cat.
Yes, yeah. I should get her. My cat's star on all my presentations.
Yes.
She's going to be very noisy. Chupacabra.
What's her name?
Chupacabra.
What is it? Chupacabra. Chupacabra, o nome da gata.
You're gonna, when I come to talk, so do my cats. So you'll have to forgive me for the cat noises because it's definitely going to happen. Thank you, Chupa.
You are forgiven.
So, let's see. So, there's another important kind of political layer here, though, to talk about, is that the people that introduced Bitcoin were also kind of coming from a particular, a little bit radical political perspective that's cyber libertarian in nature. And so, the technology, they put it together in a really interesting way, and very, very creative act that created something that's changing the world. But it's also important to remember that they came from a kind of politically radical place, and a place with a lot of hubris, right? And we'll talk a little bit about those political ideas here and how they haven't really worked. But they really do come from this kind of very, very interesting place politically. And of course, wildly successful. When Bitcoin first came out, I'll admit, I thought to myself, yeah, this is not going to work. This is not going to be important. I wish I had not thought that, obviously, as most people at the time may very well assume. I wish I had made some Bitcoin in 2009. I did not make any Bitcoin in 2009. So I'm still working, my friends. But so it's a super successful project that really is changing so many things, and it's very, very important. The original version of it, though, using what are called proof of work algorithms, is just really, really wasteful. And that's been another reason that I've opposed this, really since it was born. But let's talk about these cyber libertarian sort of political goals that were an important part of the early days of Bitcoin and cryptocurrencies. So one of the goals was to obviate nation-state controlled central banks. This was against central banks. The dream was to create a global currency that would replace all national currencies. And these are ideas that come from, the Austrian School of Economics, kind of a liberal libertarian branch of economics. And, a very, very kind of interesting goal. Also bound up in some of these cyber libertarian dreams, also kind of related to this sort of, similar thoughts, sometimes accepted, sometimes rejected within libertarianism, but are some pre-modern ideas or notions of currencies that are based on some notion of intrinsic value. So the gold standard was the idea that, our currency, our money, should be based on something with actual value like gold. But of course, the idea of a currency is in fact, a completely cultural phenomenon. Money has whatever value that a group of people assign to it through our collective behavior. That's what money is. But there are some of these kind of pre-modern notions of pre-modern economic notions that many of the supporters of Bitcoin really kind of strongly supported. Another goal, of course, and worthy goals, valuable goals, is personal and individual privacy, personal agency, individual liberty, were ideas that were built into the production of cryptocurrency. And really, none of these have been accomplished by pardon me. These things have not really been sustainably accomplished by cryptocurrencies. Some of the newer cryptocurrency projects that exist completely abandon these goals. I mentioned two here, Ripple and Stellar, XRP and XLM. These cryptocurrencies are designed specifically for banking. They specifically implement at the software level ways to adhere to international money laundering laws. So these are made for the banks, right? There are cryptocurrencies that are made for the banks that have, that are participating in the destruction of the cyber libertarian dream behind, and I'm not celebrating that, but I'm just saying that it's real. It's sort of the destruction of the cyber libertarian dream that was a lot of the kind of intellectual fuel that fed the development of cryptocurrencies in the first place. So let's move on. Oh, Chupaloo, I know. We're going to get some food. We will shortly. in about an hour. Okay. So, all right. So getting back to the waste issue, Bitcoin and certain non-fungible token exchanges are based on this proof of work. It involves solving difficult cryptological problems in order to win the opportunity to verify that transaction on the network, on the blockchain. All of the nodes that are actually making a cryptocurrency or doing the validation and verification of problems kind of vote on this together. There's a consensus. They're all based on consensus algorithms that somebody has won the right to do that. Winning nodes get a little bit of a reward from some source, different with different cryptocurrencies. Some cryptocurrencies charge fees to the people that are doing transactions. That's called gas. If you're doing non-fungible tokens, you'll have to pay gas cost to mint your cryptocurrencies, things like that. Proof of work algorithms are really computationally expensive. It uses a lot of electric power. Chupa's joined us. Hello, Chupacabra. It uses a lot of electric power, which produces a lot of carbon emissions. Next slide. And I want to give a shout out to a colleague of mine, Professor Memo Acton here at UC San Diego in the Department of Visual Arts. Memo is the scholar who has done, and by the way, he's a fantastic artist, does amazing work with artificial intelligence, visualization, installation work. I really do want to refer you to his work because he's a really remarkable artist. He's also a computer scientist who's done a lot of the really, really important work on the ecological cost of cryptocurrencies. So this is the really kind of famous paper, post on Medium, The Unreasonable Cost of Crypto Art. It comes in 3 parts. And, it's not entirely anti-crypto art. It's just, it's really mostly against proof of work as a way of doing this. And also interestingly, I wanted to point out that, Dr. Acton is somebody who makes non-fungible tokens. I put his URL here so that you could go take a look at some of his artwork. The only artwork we'll look at today, Hikanuk, which is a Brazilian NFT, non-fungible token exchange, where people can, quote unquote, buy NFTs. So it's a really, really interesting one. Low environmental impact. I would say it's the place to, if you're going to make non-fungible tokens and sell your art this way, I think this is the way to do it. This is the place to do it. Maybe I'll start putting some things there. I get a little inspired sometimes. Maybe I will. So anyway, Dr. Acton has done really kind of the most famous work on the costs, the ecological costs. But for a long time with crypto, this has been my main argument against them, is that it's really just burning coal to, it's really releasing a lot of carbon in order to do that. These are some pictures from the Kingston fossil plant, coal ash slurry spill. This is a place in Tennessee in the United States, one of our states, where a lot of coal ash left over from electrical power generation was being stored in a way that wasn't sustainable and near a river. And basically these ponds of coal ash escaped, got into the river, ran over houses. You've seen mining disasters and energy disasters like this in Brazil. This is one of ours. But if we look at the pictures, though, are these piles of ash really what cryptocurrency is made of? Right? Becomes the important question. The next slide is on the economics of carbon dioxide and coal ash. So again, just as with fiat currencies, national currencies, A currency is only worth what a marketplace of humans values it as. It's what we're willing to exchange it for that provides a currency with its value. Currencies are important catalysts for marketplaces, so that, people can trade a broader range of products. I mean, it's one of the fundamental, human discoveries in economics has been, currencies and coins and symbolic media of exchange. So value is obviously not the physical property of anything. By the way, this includes things like gold, right? Gold is something that's more or less valued at different times in history, even though it has obvious applications, even though it's rare, doesn't mean that it needs to be that it has intrinsic value that make it functional in terms of operating as a currency. Gold standard people are completely wrong. The value of gold is what we, as a society, place value in it. That's the value that it has. So the value of a currency or the value of any particular commodity is really a cultural invention. It's our culture participating in economics that produces the value of things. So reais and dollars are printed on paper. We know that. We know paper isn't worth very much, yet they still have authority. And why do they have authority? Well, it's because nation states have militaries and corporate industrial complexes, that can back the medium of exchange that the political, agency of the state demands that people use for exchange, so that things can be counted and taxes can be collected. Bitcoin itself is actually printed, instead of on paper, it's printed on spent carbon, spent electricity. I like to pause there. It's actually Bitcoin is really made of a negative value product. What is a negative value product? Garbage. Garbage has negative value. It's a product, but we don't pay people. You don't pay somebody to get some garbage. You pay somebody to take the garbage away. It has negative value as a product, and it costs you money to have garbage. So, Bitcoin is kind of minted or printed, on this really negative value substrate, but we still assign it value culturally. And an important point that's often made about these things is that Bitcoin doesn't have a military. So all of these kinds of cyber libertarian ideas that Bitcoin is going to replace national currencies, it has no traction. You may know from the news that China is outlawing all cryptocurrency, and they're pretty serious about it. The state can make a cryptocurrency disappear and lose value and not allow it to be used, again, because Bitcoin has no military, Bitcoin has no police. So a lot of these sort of cyber libertarian dreams have been sort of, erased. They were never practical to begin with. Next slide. But, and this is the good news, for at least ecologically speaking, is that there are alternatives to proof of work. And I guess also some good news is that, these do become kind of commodities of exchange that are also alternatives to national currencies. It is happening. You are also aware of the news, I'm sure, that the nation of El Salvador has accepted Bitcoin as one of its official currencies. So just like the nation state can take away, the nation state can also give credibility to cryptocurrencies. It's not something that flows in only one direction. So anyway, back to the technologies themselves, is there are other ways other than proof of work, which is very computationally complex cryptographic hashing to try to solve some riddles to win the position of being able to verify a transaction on the blockchain and then get some rewards back for it. There's some other ways to do it. I'm not going to go into great deal on these. The main one is proof of stake. And proof of stake can be very computationally inexpensive. And I think this is important for not only for ecological reasons, but for some other reasons that I'll talk about today. Proof of time and space is another one. That's the one that the Chia cryptocurrency that I was talking about earlier, Bram Cohen's project, is made of. That, to really summarize it in a kind of gross way, instead of using processing on your CPU to verify transactions, you prove that you have storage space on your hard drive. It's using hard drives instead of CPUs in some very, very interesting and clever ways. My big point is that once you free, this is really important, I think, with cryptocurrencies, once you free the CPU from wasting energy and effort on proof of work verification, then these kinds of crypto networks of computers it opens up space for them to do general computation, right? What we could just call as a crypto network could do distributed processing exactly the same way or in similar ways, really, via peer-to-peer that Boink and SETI at home did processing, right? So it frees up these kinds of networks of distributed computers that are controlled by, anybody who wants to contribute the processing power to networks that can solve some of our problems, that could maybe solve many of our, or at least help solve our problems with big data that I mentioned earlier. And to me, this is what's really exciting about cryptocurrencies, right? Is that they can create networks for general purpose computation. That's what I'm excited about much more than non-fungible tokens. But you asked me to talk about non-fungible tokens, and they're not a complete waste either. So I do want to share some ideas about that with you. Okay, so the next slide, I believe, is what is a smart contract? All right, so we've got, for just cryptocurrencies in general, we have some concepts. It's a network of, the Bitcoin is a network of computers, right? Doing Bitcoin work. They're Bitcoin peer-to-peer agents that are doing work together. I think I glossed over the idea of a wallet. I think I maybe missed that slide. But that's okay. A wallet is really just, all a wallet is it's a private and public key pair that can be associated with transactions on the network. Okay, so that's another important element of this. Smart contracts are kind of a newer idea in cryptocurrencies. So starting with the Ethereum cryptocurrency, which is the world's second largest cryptocurrency behind Bitcoin right now, you could secure, the cryptographic work that allows securing of transactions in the blockchain aren't the only thing that can go into the blockchain. Another thing that can be verified and secured into the blockchain are programs, right? Or as they're known in the crypto world, they're called smart contracts. And these contracts, which are programs which can execute on the network, right? So an Ethereum smart contract is a program that can run on the network of computers that manage all of the transactions for Ethereum. Well, and I put some other things in here. But Ethereum, by the way, started out as proof of work, and they switched over to proof of stake. So Ethereum is greener than it used to be. These idea of smart contracts are associated with something called DeFi or decentralized finance that I'll talk about a little bit. And really, it's decentralized finance and a lot of the ideas from decentralized finance that enable the technology that we know as non-fungible tokens. I'll try to explain all of that. But importantly, smart contracts, next slide. A smart contract is really just a computer program that can also do general purpose computing on a particular network. So what a smart contract is a computer program that can run on the distributed environment of computers in a crypto network. And really, that's all it is. It is just a program. One of the things that it can do on that network, though, is perform transactions on that same network. So a smart contract can do things like send some cryptocurrency to somebody else on the network at a certain time, or when certain conditions are met, which gets scary. I'll get to that. But it can, it can do things on the blockchain separate from individuals and their wallets doing things on the blockchain. It can do things to people's wallets, which is really interesting. So let's look at some different kinds of cryptocurrency just quickly. The next slide, kind of a digression, but I want to maybe one of the things I want everybody to learn today is that, and I'm not saying that this is going to be a good taxonomy of, it's not. I haven't made a good taxonomy or a thorough taxonomy of the types of crypto projects that are out there, but I did want to mark some of the major categories of cryptographic projects. Some of the main areas. So, as mentioned really today, the original idea of Bitcoin was to create a currency or a store of value. So it'd be a currency. Bitcoin would have a value. It'd be able to maybe exchanged for goods and services, etc. So these are cryptocurrencies like Bitcoin, but also Litecoin, Zcash, the famous Dogecoin, these networks are really designed to treat the fungible coins, the exchangeable currencies, as stores of value, and they're a little bit limited to that. That's what they do. They're meant to be currencies, but some newer ideas entered the cryptocurrency universe, primarily in the form of decentralized finance. So these are coins that you hear in the news a lot now as being the next thing. Ethereum, Solana, Cardano, new one called Avalanche, Tezos. These are all newer cryptocurrencies that support this idea of smart contracts. And most use proof of stake. Most are greener now. The cryptocurrency marketplace has really moved on to where a coin is not only a store of value, but a coin can do things like manage a financial network. These networks are capable of doing distributed finance activities. And there are even more. I didn't list them. There are hundreds of different coins, different crypto projects, crypto networks that we could talk about here. But some of these decentralized finance cryptos are really specialists at particular things. That's kind of interesting. One that you hear about a lot is called a DEX or DEXs. These are places where you can exchange one kind of cryptocurrency for another kind of cryptocurrency. So if you have some Bitcoin and you want some Solana, you can exchange your Bitcoin for Solana on a DEX. These have their own governance tokens, which are almost like currencies associated with them. So these are things like SushiSwap and Uniswap. Another decentralized finance idea is something called a stable coin. These are things like Tether, coins that are bound actually to a national currency, right? Once again, there goes the cyber libertarian dream of cryptocurrency. Some of the most popular cryptocurrencies today are indexed to the United States dollar, right? Which is, they're pegged to a currency so that their value is always the value of a dollar. These play a really, really important role in, having different kinds of mediums of exchange or mediums of international money exchange. There are cryptos that are made for international money transfer, for remittances. Those are the ones I showed you earlier that are, also the dream destroyers, right? This is Ripple and Stellar. These are made specifically for transferring money across international borders, but that also implement most of the laws about knowing your customer and anti-money laundering laws and things like that. Still in development. We don't know really where these things are going to land, but they exist. There are all kinds of others. And this is where things get really scary. I'm about to go to the scary part. There's asset management, like places where you can put your crypto and do things like manage risk, which is, more commonly like Wall Street stuff. Lending, where you can borrow crypto, or get interest on your crypto. There are cryptocurrencies like Compound. There's one called Compound that will give you interest. This, and then really scary is derivatives, right? What Wall Street banks do that led to the 2008 crisis. Because of smart contracts, you can kind of create bets on financial markets that are, highly synthetic contracts that, the value of the derivative will go up. If this cryptocurrency goes up, it'll go down if it falls. It has to do with risk management and short sales and long sales and all this finance stuff that honestly makes my eyes glaze over. But I just want you to know about it. And because these are all basically banking, right? Crypto projects that are sort of reinventing banking in a distributed environment, they're starting to get regulated, right? The United States and the European Union and, other great powers around the world are beginning to create regulations. It's really starting with stable coins. The United States is about to make laws about what you have to have backing a stable coin. And the recommendation is that it's, hard assets, dollars or gold has to back up a stable coin. If a company's offering a stable coin, they have to back it up with, very, very liquid assets. So regulation is coming to this, right? As cryptocurrencies become mainstream, regulation is entering. Okay. And by the way, I mentioned on that last slide, China is banning crypto. Okay. That's regulation too. When you make something illegal, that's regulation. All right. I also just really mentioned quickly, there are, utility tokens. This is kind of an interesting area too, different. We're not going to talk about it at all today, but it's an interesting area of the evolution of cryptocurrencies. There are these coins that are being made for specific activity. So like one of the most famous ones is the basic attention token. If you use a web browser called the Brave browser, they will pay you, they will block all the ads, but if you want to look at ads, they will pay you to look at the ads. You can click on them if you want, and if you do look at an ad, they will pay you in a cryptocurrency called basic attention token. So BAT, the basic attention token, is intended by the company that creates the Brave web browser, which is based on Chromium, which is the Google browser. Their idea is that they're going to recreate or, give a fresh start to internet advertising by allowing people to, be paid to look at ads. Also create a marketplace where people who want to do advertising can reach people who really want to see their ads. There's great hubris in this project, but it's also kind of a marvelous project. And, if you don't have any cryptocurrency, you personally, you have nothing, you've never done anything crypto, get the Brave browser, do its setting, do the setting where they, will pay you to look at ads, and you will now have cryptocurrency. They will pay you in a little bit of basic attention token. And there are other ones. Oops, I misspelled the central. I think it's one L there. Okay. There are other crypto tokens that are out there. I don't think I had the slide, by the way, in the original one. If you're looking for it, I'm sorry I threw you. I just wanted to put the idea out there that utility tokens are a thing. This is just like NFTs, utility tokens is this frontier of cryptocurrencies and crypto. I'm on distributed computation networks. Now, this is just my opinion. I told you I was wrong about Bitcoin. Wrong. So, if I make any predictions about what's important or about the future, you should take that, as just my predictions. But I do think that these are what are important in the future for kind of cryptocurrencies and this world that leads us to NFTs, which are distributed computation networks. So I said before, once we no longer do proof of work, right, that frees up the computers that are participating in the network to do other kinds of computation. And in fact, to make that computation a service for which you can exchange a cryptocurrency. So, Internet Computer is kind of an interesting one. They are a cryptocurrency network that sets up primarily in major data centers, right, who want to make some extra money. And those data centers can sell their excess computation, their computers that aren't being used, to people who have ICP, or the Internet Computer Token. So you can buy some Internet Computer Token, and you can use that to buy compute time to run your programs, maybe over a scientific data set, or maybe to host a website, right? Same with Filecoin, very, very similar. Storage, very similar. Storage is really what storage is it's P2P file sharing, except people can pay to put their file into the storage network so that people can access that file, or so that that file can be securely stored for a period of time. And you pay with that token to store files. So what I'm talking about here is these are crypto, fetched as AI. There are other ones that I've listed here. But, this is what I see happening is I see crypto moving from this somewhat naive idea of a currency or a store of value into tokens that can be used to pay for actual work that you want to do with computing. In other words, one of the things that crypto is becoming is supercomputing, right? Distributed compute with, when you need, 1,000 computers to run a job on, you'll be able to buy 1,000 computers and do the computation on something like Internet Computer. That's the name of the cryptocurrency. Making a bigger computer out of the internet is sort of the idea. And these are the things I find really maybe more interesting. But you asked me to come here and talk about NFTs, so I am going to do that. And I do think NFTs are interesting. I think I'm on the first non-fungible tokens slide here. So we finally arrived. So blockchain technology can also do some other really interesting things. One of them is verify the existence of a group of ones and zeros, and that it existed at a certain time on the network. So what a non-fungible token, well, what is non-fungible? Well, starting with the idea of cryptocurrency, the thing that you were storing on the network was all the same kind of thing. It was a Bitcoin or a fraction of a Bitcoin that you had control over. And your Bitcoin was like all other Bitcoin, and you could exchange it for things, like heroin on Silk Road. That's an older story of early crypto. Look up Silk Road. It's a pretty amazing story from the early history of Bitcoin, where all kinds of illegal things began to be sold online using Bitcoin. But all Bitcoin is Bitcoin, right? It's not something else. Well, the same technology can be used to verify that a set of zeros and ones existed, right? In other words, you can mint something that is a one-of-a-kind object instead of a universal medium of exchange like a currency. So what do non-fungible tokens do? Well, there's a wallet that provides the who. These are the creators or the owners or the fractional owners of something, of a group of ones and zeros. I say owners loosely here. We'll talk about that. The time. So one of the effects of the blockchain is it records the time when a token or when a transaction was made. So if you have a group of ones and zeros, you can prove that that group of ones and zeros existed at a certain time on the blockchain. This is very interesting. This is very useful for history. Don't type for me, baby. Oh, you good girl. You good girl. She likes to, this is her first time actually getting online. It's usually my other cat that likes to make appearances. The internet was made for cats. You know that. Right? So they record the time. They can have smart contracts involved with them. So one of the interesting ideas in NFTs is that the smart contract feature can, for example, let an artist create an image, put that image on an exchange. Other owners can purchase that image. No. Other people can purchase that image, and it's recorded on the blockchain that they are the purchaser of that image via their wallet. But if they resell it, the smart contract associated with that function can, give the original creator, go on the floor. The original creator can get paid again. Every time something is resold, the smart contract can send a percentage of that to the original creator. That's okay. That's pretty neat, right? These are very, very interesting things that have gotten people, especially creative people who are, making images or music or things like that, interested in using the internet to sell their work. And that's really, now we have everything that we need to understand what an NFT is. Non-fungible just means it's a unique thing that's been recorded. The unique thing is specifically literally a string of ones and zeros, using hashes to prove that unique string of ones and zeros existed. The string of ones and zeros aren't stored on the blockchain, but their existence, that they existed at that time and that they have some rules associated with their exchange, is recorded. Next slide. And that's really what an NFT is. That's what it does. And these are some important things, often pointed out, not my original idea or point by any means, but when you buy an NFT, you're buying a place on the blockchain. You're buying a record on the blockchain that associates a digital file with you. When you mint an NFT, right, you have an image, you put it into the system. When you mint an NFT, you're associating yourself as the creator of that. And you might also associate a smart contract with it so that it can be resold. Other people can buy and sell it. But importantly, this is not an actual legally defined right in any way right now. Ownership is being used very loosely here. It's really nothing more than maybe bragging rights, right? And whatever it is that the smart contracts do is really what you're paying for. Importantly, there is no international convention with non-fungible tokens that transfers any legal rights to the image. So an important right with an original creative product is copyright. And NFTs have nothing to do with copyright. Now, anyway, right? We haven't, the legal system could evolve to where the legal system in the international community recognizes that a copyright can be transferred with a non-fungible token. That could happen, right? That's just a matter of nation states making laws and agreeing to honor each other's laws through, treaties at the United Nations or through other international bodies, right? But for now, NFTs are nothing. They're absolutely nothing except a kind of fun internet activity that people take very seriously and that some people make a lot of money with. In the early 2000s, I used to use, it's still around, something called Second Life, which was a virtual world. And you could go into this virtual world and use its tools to make and write programs that were attached to virtual objects. You could build houses or make inventions and things that people would buy and sell. And they have a virtual currency. It's not a cryptographical currency, but they have a virtual currency in a marketplace so that you can take the money you earned in Second Life and Second Life lindens and turn it into dollars or many of you will know Second Life. It was very popular for a while in Brazil as well. And, it still exists. Lindens are still a real thing. They still have some value. They can still be exchanged for dollars. So again, currency is simply what a society grants to as value to particular symbolic designations of value. But so NFTs do have a culture behind them, and real value is exchanged. I just want everybody to know that there's no legal value to it. It's more like buying a virtual object in Second Life. One of the utility tokens, it's very interesting. I recommend it. There's Decentraland. It's a web-based virtual world that you can get into, that you can enter just through a web browser. And you can walk around and you can interact with people's creations. It's a little bit like the original idea of Second Life. They have a cryptographically based, cryptocurrency called Mana, which is for buying and selling things inside of that one virtual world. But you can exchange dollars for it and invest in Mana, even if you don't go into Mana. Some of this is sort of like an imaginary fun money, and we don't know where it's going, right? But that's what an NFT is, and they have obvious value. I think some of the great values of this technology is you can record that something existed. There's a famous website, archive.org, which has the famous Wayback Machine, and archive.org is a library that has been recording websites. So you can go and look at early Amazon, or you could look at the Amazon website at different places throughout history, or my old website, which doesn't exist anymore, or they're trying to collect the entire history of the World Wide Web as websites as the web changes. And who do we trust? It comes down to who do we trust? Well, we trust the library, right? Very, very interesting thing. When Donald Trump was elected, archive.org, by the way, is a project that's in San Francisco. They became very, very worried that people from the new administration might want to rewrite history and remove embarrassing things from the history of the internet. So they copied the entire archive of archive.org and the Wayback Machine. They made a copy of that, a mirror of that in Canada, where maybe a fascist government could not go to insist that history be rewritten by changing old websites to what they didn't say. But the agent of trust in archive.org is archive.org. It's that agency, that organization, that library. We trust them not to change the history. Well, with NFTs, we could prove that this web page said this in 2021. We could prove that this wasn't made later. And that's a really, really valuable aspect of this technology that I think is great. I mentioned Algorand, which is a altcoin. There was big news about El Salvador adopting Bitcoin as a national currency recently. A less talked about story was at the same time they adopted Bitcoin, they also adopted Algorand, but not for use as a currency. They adopted Algorand for legal records. So something like the documents, the deed that proves you own your house can be recorded in time. That document, that PDF, if there's a PDF that has all the proper signatures on it, you can store that PDF online and you can prove that it was confirmed by the nation state or the government that's responsible for recording deeds in something like Algorand. And Algorand's that's its company, and they're very smart. They're going to all the governments, especially, by the way, in South America. They're going to governments and saying, hey, this is what we can do for you. It can also be a platform for creating, coupons and all kinds of stuff. It's a very, very interesting cryptocurrency, in fact. Look into it. It's really, really interesting. Well, they're kind of the quiet company that's sort of, not trying to make a currency, but they're trying to do other work for government, for nation states. And NFT mechanisms are really, really valuable for that. So, okay, other ways, I said, what are they really? I think I said that before, but there's other ways to think about it. It's like a like button that you pay for. If you buy somebody's NFT, it's kind of like it's public that you bought it. So that's kind of like a like button, and the amount you paid for it is sort of the how much you liked it, is kind of a fun thing. You can mint NFTs of your images, and nobody will, there'll be a record of that image, and you can make a little money. You guys should all try that. I understand this is a class or something for an entire class. You should all try to make an image and put it up there. Everybody try to make an NFT for me, and I'd love it. This would be great if you would all make an NFT for me and then send me the URL. I would really love that. I'd love to see your two-dimensional visual artwork or music or whatever it is you make, and I'd love to see it on a any of the NFT sites that doesn't use proof of work. Definitely use a proof of stake site, and I will look at it. I will look at your work. Now, other things can happen, right? How long does a blockchain live? Blockchains can die. They can go away. So there are these kinds of risks that are involved in a blockchain. As we learned earlier, depends on very specific internet protocols, including TCP/IP and peer-to-peer protocols. Do people keep maintaining the network? One of the most interesting coin projects out there was kind of a joke project, not Dogecoin, but Marx coin. Somebody made a Karl Marx coin, a crypto project, but almost nobody is using that network anymore, right? Because it was just kind of a joke. The protocol is out there. You could you could join the network and you could make Marx coin, and nobody cares about it. But, my point is that a network can either disappear or its activity can disappear, its nodes can disappear, and then there is no more of that crypto, right? Is it do governments stop it? China is stopping all crypto apparently right now. We'll see how long that, particularly as regards banking, but we'll see how long some of this stuff lasts. On the other hand, there are some nations like El Salvador that I mentioned, but Peru and Ukraine and others, which are in various ways enabling crypto economies. So, one of the things I do predict, and I think it's pretty reasonable to predict this, is that there will be nation-state competition over cryptocurrencies, right? China has said they're going to come up with their own cryptocurrency that they could track and surveil, right? There's a reason they're banning other cryptocurrencies, because China's going to create its own yuan cryptocurrency at some point. So there will be nation-state competition over these. But other things can make cryptos go away too. Electromagnetic storms could destroy the internet. Bitcoin, as we've learned today, doesn't really do anything. It doesn't do work. It just holds value. So is it possible that at some point in history it becomes obsolete? All right, let's talk a little bit about art then, just at the end of this. Having done all this technical and historical and economic stuff, let's talk about a few things. So, right, where are some of these technologies useful in art? Well, art history in general, right? You can secure that a paper was published in a certain year, or that these artists were talking about this idea, which was an original idea in the arts, on a blog in this year. Things like that can be very, very useful for that. Kind of a distributed network that's a Wayback Machine is something that's possible. You could record, NFTs record the popularity of something. Maybe that's of interest in the long term, right? Everybody with art is interested in the record for the most expensive artwork. the values that artworks, historical or present, find in the marketplace. And that does have that impinges in some ways on art history. Most art historians aren't terribly interested in that. But it does impinge some way on sort of a recorded history of the value of certain things in certain times, in certain contexts, in certain places. But here's what I think is more interesting than putting a picture out as an NFT and reselling it. And I'm not against that either. There's some more interesting things. I mentioned earlier that I came from a time in the internet, 1993. I went to graduate school in 1996. This was a generation of artists that I was a part of that was beginning to explore what the internet was. The first thing that artists did with the internet was the most obvious thing, which was to post images of their art on the internet. And I don't think NFTs are much different. And I used the word occludes earlier too. This idea that art is visual art in a rectangle, maybe that can hang on a wall, maybe that can show on a screen, is a super conservative idea about what art and art making is, right? So, I've tried to emphasize the fact that cryptocurrency networks can also be computational networks. They can be active things that intersect with society. And I think there are big questions about what kind of software are artists going to write for crypto networks becomes important. But I'm not putting down NFTs. There's sort of an ecstasy of participation with non-fungible tokens that was also there in the early internet. We were thrilled by this new technology and thrilled by the possibility to address this new technology as artists and see what we could make it do as artists, and also to share our work. So, NFTs, there's a lot of ecstasy in them right now, just like there was in the early internet. And honestly, I've seen experimentation and play with the social aspects of NFTs as opposed to only the network. Only the images that are shown there. There is actually some very interesting kind of smarter than look at my picture work that's taking place out there. Next slide. What is computer art? I started down this path a minute ago, but computer art is not just using computers to make artifacts like music and images, right? It also includes hypertext, digital storytelling. There's interactive environments where it's the nature of your interaction with a creation that's the artwork, not the visuals that it consists of. Those are Myron Kruger ideas from the 1970s. Installation art, site-specific work. This is what I'm working on right now. Is I'm kind of doing glitch music for particular places in the United States. That's what I'm working on right now. That relates to some other issues far from computing. I'm really working with religious music and delusions and cults and things like that, because that's kind of what I want to do with the sabbatical, is drive all around the Western United States and camp a lot and do site-specific installations with noise. That, glitch music. That's what I'm doing these days personally. Digital sculptures and robotics. Robots as sculptures. That is also computer art, right? And while you could create an NFT of a picture or a video of your robotic installation, right? It's different. It exists separately as an object that is not so easily virtualized. But there's virtual reality and augmented reality, AI, traditions of artificial intelligence and art making, which may impinge upon the world of these crypto networks, but also have installations and ideas that function outside of that. Artists who make computer games. Yeah, you could create an NFT of the binaries for a computer game, no doubt about it. But really, the experience in a computer game is the experience of the players. So when an artist makes an art computer game, how do you, what is the role of NFTs in, it could be used for documenting that experience that people had with artist games. But what are artist-made games as an art object relative to the world of NFTs? these are interesting questions. We will make discoveries about these. Live audio visual performance. The reason I started coming to Brazil in the first place was in Sao Paulo was your very important computing in the arts festival called FILE. And FILE also hosts a music sound performance art festival called Hypersonica, right? So, what do these mean to something like a live performance in front of an audience that is also computer art, right? What does it mean? In other words, computer art is much broader than making pictures for people. It's much more interesting, I argue, than making pictures for people. Gallery practices. A lot of what we do in the art world revolves around some ideas about the gallery and the cultural ontology of the gallery as a special place for making propositions about art, right? What is the NFT work of the actual physical art gallery going to be like? What kind of ideas I look forward to this. I'm excited about, where people are starting with NFTs and what they're going to do with. I'm excited enough. I might make my own NFT. Who knows? I might make one myself. Then I'd be more qualified to speak to you about it, wouldn't I? Digital art is much more than NFTs. Just to round things out today, we're in a live history. There are interesting technical parameters to work through. I happen to be an artist who's doing site-specific glitch music, but for deep in the desert and very remote locations. So I've just been able to, like I said, transparently, this is not my area of expertise. I just want to have some ideas with you and share some ideas with you because that's what we do as academics working in our field. I really think the future of crypto is really more infrastructure. I do. I think, I think the really interesting areas of cryptocurrencies and crypto network systems are going to be in distributed computing. I think they're going to start to compete with, Amazon and S3 and S2 and all of Amazon's online cloud services, basically allowing a competing infrastructure, where you could buy computing services. I really think that's where crypto's going. And a few things, in the 1990s, when I was in graduate school at Cadre, we always said, about the new internet, going back to that idea of the new internet, is that we wanted to talk about art of the internet, art that was native to the internet itself as a particular medium, a specific medium, composed to putting offline ideas about art onto the internet. And the very basic idea of an NFT is to put, an image, maybe digitally created, maybe not. It doesn't have to be either way, just because it could be captured by a CCD and turned into an NFT. Okay, fair enough. But, it really is about this more traditional idea of the artist who makes a picture for somebody. It's a little boring, actually. Not that there isn't good work there. There's always good work of visual artists that are showing images to each other. I'm not saying that, but I'm saying the gesture of the fundamental gesture of an NFT is not at all revolutionary. It's just really just facilitates a way, and I'm not against it. Make your money, but I'm just saying that from a perspective of art history, the development of art history and new ideas in art, it's a nothing. It could be something though, because maybe artists start to make something out of the crypto networks instead of making things to put on crypto networks to look at. And that goes back to ideas from early history of net art, which Cadre, I misspelled it there. Oh, it's CADRE. That's the graduate program and undergraduate program at San Jose State University, which is a great place to think about graduate school for all of you. For anybody who's an undergraduate at Pookie and doing related things, that's a great place to think about graduate school in the United States. And we're just at the beginning of crypto art, and I just see us as being kind of at 1993 again, right? We need to overcome the idea of an artist showing an audience a picture and move on to things that are more about the networks and the internet and these, cryptocurrency networks that are being created using peer-to-peer technology. Because I think that's where the real interesting work is ultimately going to happen. Okay, that's it, my friends. I want to thank, Jane and Marcus again for inviting me. Thank you so much. It's great to be back at Pookie. And thank you, Laura, for helping arrange all this and guide me through the project, and to our translators and sign language interpreters and everybody who worked today. Thank you so much.
Brett, I have to thank you. It was amazing. Actually, I learned a lot as usual. And it was very interesting to understand, the history of crypto projects, and the relationship between the crypto projects, all crypto projects and NFT. And sometimes because we think about NFT only for art and that's it, which is nothing. You are right. It's nothing. It is much more than, making images and showing images for people. And I have here some questions. I could use, lots of time asking questions, but I think that it's going to be better to have them asking questions. And what I think that I'm going to do is that I'm gonna, you can read the questions there, for example, and then we can start a conversation with some student, like, Carolina. We can start with the first questions. I think it's
okay.
fair.
I'm looking at the.
Okay.
Oh God, there's 120 comments.
Yes, a lot. But it was mostly they are mine. Trying to translate some parts. That's it. Don't worry about that. It is. Oh, I think that the first one was Carolina Naspitz. Is this right? Luana, BitTorrent. The Carolina Maria was asking about the torrent is the same as BitTorrent. I don't know how to answer that.
I don't understand that question.
Because they use torrent. The BitTorrent, it is the same as torrent.
I think so. I think torrent is a short. Yeah, it's a
short version of BitTorrent.
A torrent is something that a torrent is actually an entity in the BitTorrent network. Yeah.
Okay.
And sometimes people just use torrent. Yeah.
Okay, and then lots of comments about your cat, Chupacabra. So cute. And
she's 17 years old.
17 years old. And there is a comment by Isa Tafuri. It's so weird to me. Bitcoin feels imaginary.
It does. I mean, that's its importance, right? It starts from this place of unrealistic political hubris, I will say. Coming out of cyber libertarianism, just delusional, unrealistic dreams of replacing national currencies, right? As soon as Bitcoin has an army and military, maybe. But until then, it's delusional, right? But it really did unleash this. Both it furthered the technology through putting these different pieces of technology together to create something new, and it has definitely stimulated it's sort of in the world of crypto right now, where much of the present technological imaginary is taking place, and there's real computer science innovation taking place in the crypto world. So, it ends up being as important, I think, as the internet, right? I think Bitcoin is as important as the internet. Ironically, Bitcoin was born from some delusional ideas, but became very successful. So it's really kind of a remarkable cultural phenomenon that history won't forget.
Isa Tafuri, você quer alguma outra pergunta sobre esse detalhe do Bitcoin? I'm asking Isa if she wants to ask something, anything else about the diffuse imaginary. And there is another question, meanwhile.
Oh yeah, the imaginary.
Carolina,
it's interesting because reais are imaginary too, right?
Yes.
Yeah.
But on the other hand, when you were explaining the Bitcoins and the crypto coins, I had the same, feeling that there is a concrete feeling about computational program instead of only imaginary, which is very interesting because sometimes, you can almost touch when you think in terms of computer program.
Computer programs are very, very real.
Yeah,
they happen. They do things.
They happen. Yeah.
They happen on a physical substrate of silicon. They're very real.
Yes.
There's nothing imaginary about them. They're very, very concrete.
And then we have this kind of duality between the imaginary and this concrete real thing at the same time.
Yeah. And the consequences of programs, right? Some programs running don't have much consequence. Other programs running can, be billions of dollars in 1 second.
Yeah.
That's
it. There is another question by Carolina Naspitz. She's saying that the invisible technology always seems clean and light, but it's always the opposite. This kind of storage, the cloud computing storage has nothing to do with the cloud. It is, like a bunch of buildings full of HDs and servers with a very heavy metal.
Yeah, and using a lot of carbon. They're connected to electrical plants that are burning coal, right? It's very, very interesting with crypto because the crypto industry, if you will, is trying to clean up. El Salvador is a very, very important example of this. El Salvador, it was in the news just yesterday, they opened their first data center to mine Bitcoin because El Salvador, the nation state, is going to make Bitcoin. They've bought some for their country, but they're going to make their own Bitcoin too. But they're doing it with geothermal power from volcanoes. So they're using a cleaner, energy source. So Bitcoin, the computation, even though it's very expensive, could be clean, but it's also, proof of work algorithms are just marvelously inefficient. So even if you have solar power, why waste it, right? So the proof of really one thing that is changing rapidly in the whole crypto world, it's already changed. It's already halfway to complete, is that, proof of stake has become the new underlying technology that requires much less electricity. And I mentioned some things like Chia coin that use a different strategy, proof of time and space, but proof of stake has really become, and that means that if you want to make Bitcoin, you have to risk some Bitcoin. And that increases your odds of being the entity that can then cryptographically secure that block of transactions on the block. And these turn out to be just as secure, but use much less electricity. So that's a technical change that's going to happen in the background. It also has it has some very tangible effects also. Bitcoin's slow. Bitcoin's very slow to make a transaction. Some of the newer cryptocurrencies are very fast.
But do you think that proof of stake is more a gambling?
Oh, yeah.
Yeah.
It's always been gambling, though. Bitcoin started as gambling. It's just, how heavy are the cards you're playing with, kind of.
But proof of work is, it goes to the opposite. Instead of being gambling, you can we think about
proof of work? Proof of work is still competitive gambling. It's just machines trying very hard to guess the answer to then win some Bitcoin and have the right to secure the transaction. But proof of stake uses less energy to still do some work and distribute rewards back to the nodes that do the validating and the verification. So, it's a much better way to do it. And, this is important for NFTs too. The Brazilian site that I mentioned, Hookday, I forget the name of it now. It's in my slides. It's the place where Dr. Acton, Memo Acton, sells his NFTs. It uses a currency called Tezos, which is a proof of stake currency. And so the transactions are very, very, both economically inexpensive and also computationally inexpensive. So it's a much greener place to make NFTs. And it's a Brazilian project. You should be proud of it too. It's a very, very, it's a very cool site, and it's.
You mean Iketnunk?
Yeah, Iketnunk. It's great. And when I say that the transition is happening, we're going to move away from OpenSea and toward.
What I love about this project is the name of it, because Iketnunk means now and here and now.
Yeah, literally what NFTs do.
Yes.
Is mark the here and now. That is their function. Yeah, it's brilliant. Yes. It's very good.
Yeah. And there is another question for you. Hi, Brett, by Carolina Aspitz. Do you think NFTs can become cheaper, more affordable? How would that happen?
They are cheap. NFTs are very inexpensive. You just have to buy work on here and now. You can go right now. You can go right now to here and now. How do you say again? Because my pronunciation. Iketnunk. Yeah. Go there right now and buy an NFT. Very inexpensive.
Iketnunk.
Yeah. Very inexpensive.
Yeah. Iketnunk. Yeah. And
if I put some NFTs there, I promise. Less than 10 reais for all my NFTs. I'm sure of it. I believe this.
And there is another comment by another Carolina Maria, saying that Nyan Cat is a big NFT. Do you know this meme?
Yeah, that meme became an NFT. Yeah, it's amazing, isn't it? They're in it. There are all kinds of, and that is actually more like an art project than putting a picture on an NFT site. Is like to create a cryptocurrency. I mentioned Mark's coin. Now, it was kind of a joke, but
yes, it is.
Mark's coin is also more like an art project because they're using the medium of making their own system, right? I like that very much. I wish Cicero Silva was here right now because he's an artist who actually works with the systems of making NFTs or making cryptocurrencies, in fact, doing some really interesting work. So there's some great people in Brazil to talk to about this who are actually working with this. I'm an outsider looking in. I mean, as I've told you, but there's some people that are doing marvelous work from inside of the crypto world, and they should be very interesting to you.
And there is another comment by Carolina saying that maybe, do you think, or I don't know, that we will live inside blockchains someday? We will be living inside of blockchain someday.
Yeah, I don't know. I can't answer. We know we can't do it right now, and we know we're nowhere close. Yet, quantum computing is making some interesting improvements. We're still very far away from quantum computing, but it's made so. When we do solve the engineering problems behind some of the theoretically possible things, it's a very old idea in science fiction, downloading your brain into the computer.
Yes, yeah.
Maybe, though, maybe. Right now, though, brains are very different from computers. the kinds of artificial neural networks and deep learning networks that constitute the main recent developments in artificial intelligence really are nothing like brains. The kind of neural computing that IBM is doing, where they're making chips that have cells that are actually like silicon cells that are modeled somewhat after biological cells in terms of their organization and structure, are still very, very far from what cells and the wet neural network in our brains does. They're still really far. So I'll have to punt. I'll have to give up. I'll have to not answer your question right now because I really don't know. I really don't know.
There is a question by Marcela Giannini. She asks, there's a new game called Axie Infinity. To play it, you should buy at least 3-4 axes, a pet that looks like a Tamagotchi to build a team. Every axie is a NFT.
Yeah.
And you only can buy it using Ethereum.
Yes, I could have talked about this. So many of the crypto projects are based on Ethereum as the fundamental technology for newer crypto projects. Axie is what I would have described in my presentation as a utility coin. So it's a kind of cryptocurrency only for that game. I haven't played the game, but it also makes NFTs. Very good point. I know of this actually, Marcella. I know of this, but I should have put it in my presentation. You're right. It's a very, very interesting project. It shows, it's a really great example of a token that's made for a specific environment. Now, the one that I used in my example was Decentraland, which is a virtual reality 3D environment that uses, instead of Axie, it uses Mana. And Mana is also, they based it on Ethereum, as I understand it. So, yeah, Ethereum's very important in terms of sort of redirecting from store of value with Bitcoin into computation. Most people call it decentralized finance, but it's actually more general than that.
That's a very interesting idea, decentralizing finance. Well, interesting.
It is, and government's not going to let it happen without rules. So, and by the way, do we want it? No. Do we want idiots on the internet to be able to crash the entire economy with derivatives?
No.
No.
But you don't need the internet for derivatives.
No, that's true. But after 2008, the United States at least made a lot of rules about derivatives, right? A lot of new laws.
Have you heard about Pandora Papers?
Yeah.
Of course you do.
It's in the news.
Yes,
That's how they do it.
Do you think that this laundry money from Pandora Papers has to do with the some kind of crypto coins or crypto projects?
I don't know. I haven't read them. It wouldn't surprise me though. I wouldn't be surprised by that.
Because when I read something called Pandora Papers, it sounds so far from Bitcoins or everything.
Yeah, it does.
Papers, yeah. Even though they are on internet, they are kind of files from internet. Okay, but there is another question also by Carolina. Ashton Kutcher and Mila Kunis developed an animated series called Stoner Cats that will be funded by viewers by NFTs. So they are drawings of cats characters. Owning the NFT, you can access the episodes.
Yeah, it's a very creative way to think about the distribution of media. There are so many creative ways that people are thinking about the potential of NFTs. Another one of the tokens out there is called, I had it in my presentation, I think at one point. There's Rally and there's Chili's, Rally and Chili's. These are basically systems that allow sports teams to make NFTs. But imagine this, like your ticket to get into the football match is an NFT that you can scan off your phone at the door, and you go to the football match. But another thing that the NFT does to be a better kind of new ticket for a sports fan is like it allows you to watch a replay of the match later because you bought the ticket to the game, right? Mm-hmm. Or it lets you get a discount on soccer jersey, football jersey, right? Mm-hmm. So some of the just like Hollywood is trying to think through what NFTs are going to allow it to do. It's all entertainment industry. It's sports, theater, and some of the, some projects are not being made from Ethereum as their basis technology. Some are using, like I said in the presentation, other crypto projects like Algorand to do things. So, I mean, this is a technology that is going to change everything. It's a little bit like the internet changed everything. Like I mentioned, our property records can be stored and accessed via things that are very like, your mortgage can be recorded online so everybody can see how much you owe on your house, things like that. But that, people making animated content and NFTs out of animated content, that's going to be a thing. That's going to be one of the ways that you pay for and access capitalism, which is why, by the way, capitalism is going to create banking rules for it, right?
Yes. There is a question by Marcela again. What do you think about the direct impact of NFTs on Latin America? Do you think that countries that produces cheap energy would be most affected?
I don't know. I do know that Latin America is one of the places in the world that is governments seem to be more open to adopting blockchain technology, and this surrounding countries, right? I believe Uruguay also is thinking about cryptocurrency in important ways. Peru is, Ecuador is, of course, El Salvador. So I don't know exactly where it goes. I mean, you can also be kind of cynical about some. I've had cynical thoughts about El Salvador too, right? Mm-hmm. Like adopting Bitcoin is a way for the oligarchy to get their money out of the country.
Sure. Yeah.
Right. So,
it doesn't change the system.
Yeah, it doesn't change. Well, it has different effects. It does change the system. It doesn't make the system more fair.
No,
right?
No, yes, that's what I'm saying.
But it does. Yeah. It does change the system.
It changes some system. Yeah.
But the oligarchy is still going to be the oligarchy, and we still have to fight that.
There is a question. Do you think that this type of crypto will affect the value of art in the art market and transactions?
No, not a whole lot. I don't think so. I mean, it's more of a catalyst that might open up some new opportunities. For example, I mean, I guess I should have mentioned, that a couple of artists, that created NFTs in the first place. You may not know that. It's actually a much, much older project. What they're doing right now is it's Kevin McCoy is his name, one of the artists that did this, of a really important collaboration, the McCoys in the 1990s who did original internet art. Kevin and a collaborator figured out that that NFTs were possible. They're kind of the inventors of NFTs. And they did this project, and then they abandoned the project a long time ago, and then it became something later, right? Right now, they're working on a crypto project that would help smaller art galleries easily put NFTs for sale through their own systems, so that you could, and they're working with important galleries like Postmasters, right? Initially. But, the idea is that there'll be this kind of cryptocurrency that people could, buy a piece of art, maybe even a physical piece of art, but also control the NFT. And a lot of this, of course, is waiting for regulation about copyright and ownership to catch up with NFTs. But it's a really, really interesting project. So I look at it as more of a catalyst that could make new markets. Whether that dilutes prices in the international art market, I don't know. But I mean, it's definitely something to keep an eye on. And so I don't know the answer to your question. And my crystal ball is not that good. But I do think it will catalyze change. I really do.
There is another question, the next one, which is related to this, is do you see any relation between valuation of a contemporary art piece, the fetishism, and what is going on with NFTs, fancy capitalism ruled by computation?
Yeah. Oh, absolutely. Of course. You know what that relationship is too, I think.
Yes, of course. Yeah.
Yeah.
It is the aura again.
Yeah, it's the aura. In my presentation, I called it, the ecstasy of participation.
Yes.
But yeah, you're right. In a Walter Benjamin sense, it's the aura.
Yes.
And technology can create its own aura bubble, right?
Yeah.
That carries a lot of garbage art along with it.
Yeah. There is a comment by Marcos Bastos saying "Hic et nunc," maybe when we were talking about the
it was. Yeah, Marcus, thank you. That's one. I think all of you should make a work for that. You should all go there, and you should all make your own NFT.
Okay.
And you can find my email address. Send me your NFT on the site. I want to see every person here today. Please do.
There is another question by Heitor Bonan. Do you see a future for interactive gaming environments using NFT combined with utility cryptocurrency?
Yeah, exactly. Yes.
Huh?
Yes, it's already happening.
Okay.
It's already happening. And there are really interesting, precedents to this too. I mentioned Second Life, which has a virtual currency. It's centrally controlled by Second Life, but it has a virtual currency. So things like this have already been happening. There's a history of virtual currencies in these environments. But even with, World of Warcraft, there was gold mining, right? Where people would level up characters in World of Warcraft to like level 60 characters and then sell them on markets, just transfer the credentials to another player. So the players could cheat. They could start with a level 60 character. This was going on, and this was going on as long as World of Warcraft, right? So there are precedents to these kinds of markets appearing in games, and that's both the magic and the problem of capitalism, is that it's kind of something that sticks to our species. It doesn't really matter what our ideology is. We will create systems of exchange for things that are important to us, so yeah, it's already happening. That the answer to your question is it's already real in a number of different games. The one I've actually tried is Decentraland, but yeah.
There is another kind of question by Leek, kind of Tron dream. Maybe when we were talking about the valuation or the art, contemporary art, of a kind of Tron dream. I don't know.
For real. That's already real.
Yeah.
It's already real.
Yeah.
I need to tell you where I live. I live in very remote, rural, desert California. I don't live in the city. I don't have a house really close to my house. my back fence goes into state public lands. So it's just one of my interests actually throughout my life is like very small. I live in a very small, there's only 200 people in my town, right? It's a very small community. And my wife, Paula Poole, and we go around and we study small cities, and we do work in very remote places in the American West. We go where there are no people for 20 miles to make artworks. So, you know, with Jane and Cicero, we share a museum. We have a museum in nowhere near Parker, Arizona, that only a few people know about because it's this museum. And so we know small towns very well. And I've met, there are people whose lifestyle is already Tron. Really. I have a friend who's, he knows how to build computers. Very talented man, actually. But he works part-time, like serving drinks, a bartender making drinks. He does just enough work to pay for his small room, air conditioner, and keep his computer running. And he really spends like 16 hours a day inside of various computer games. And it's a lifestyle. He has no health insurance. He doesn't care. He doesn't eat the right food. He's very poor, right? But he lives in a different world. He only comes out to this world for basic bodily functions and to make just enough money to go back in and be connected to his computer, right? And this is a lifestyle that's emerged that isn't very possible in the big cities in the United States, because in the United States, the cities are expensive and the desert is very inexpensive. So you can live where I live for almost no money, right? No services, right? Very little contact with the outside world other than what the internet makes possible. Lots of hardship, bad weather, right? We get 50 degrees Celsius in the summertime where I live. But, for a lot of the summer, humid. But there are people that live that way that have already entered into virtual worlds, and they're not going to come out. And inside of that virtual world, this man is very talented, respected, but his actual real world economic life it's almost the Matrix. He almost lives in one of those pods in the Matrix, right? So this is already happening in a lot of places. It's already possible. His pod, though, is a little desert shack instead of a pod. And he goes away to work for 4 hours in the afternoon when the bar is busy.
Brett, Pedro Libânio asks if you have seen a piece called Burned Picasso.
No, I don't know that. I don't know that piece. Sounds interesting, though.
I don't know either. Yeah, I don't know either. And there is, I think that.
See, that might be one of the early experiments that's doing something provocative with the idea of the NFT. I'll look it up. Thank you for that.
Okay. And there is another, I think that's just a comment by Hector Bonan saying that World of Warcraft would be my example if there was no 200 word limit. There is a project called Nemesis Project, an interactive NFT exhibition that happens inside a gaming platform.
Oh, that's nice. Yeah, that's nice.
Yeah, that's nice.
Okay, so I went to graduate school with, people who were a long time. Well, okay, Virtual Museum is a project by Jeffrey Shaw from 1990. Maybe it's 1991. So the idea of putting virtual objects into a virtual museum was very innovative in 1991. I'll leave it at that. Virtual museums have been done over and over again.
Yes, that's true.
In fact, it's one of those things like somebody at a film school is going to invent hypertext this year. They're going to realize They're going to invent branching narrative in their film. You're going to be able to choose your path through the film.
Yes,
and this will be new,
yes.
right? Same thing with virtual museums. Very old
Yeah.
idea.
Very old idea.
And that's a little of my point today. A little bit of my point.
I think that there is the last question, I think, because I think that we have to finish, by Leticia Wexel. What about gaming NFTs like Axie Infinity and such?
We talked about that a little bit. That's very interesting. Yeah. It is really very interesting. You know, what's interesting to me is, you know, Second Life, which is the famous virtual world that had a virtual currency that you can exchange. You can take reais and buy lindens, and then you can earn money and Second Life, and you can take your lindens and turn them back into reais. They have public exchanges for this virtual currency. It still exists. Second Life is still there. If you want to do some history research, go into download Second Life and join, and go look around Second Life and understand its virtual currency, which is not a cryptocurrency. It's just a virtual currency. And, you know, you can see that being sort of replicated with cryptocurrencies. And it's, you know, the real important, I think, formal difference, the difference in form, is that Second Life is a central database. It's actually a big cloud computing platform. They actually helped innovate what cloud computing platforms became, but it's one data center. Well, they have distributed data centers, and I think they probably, like everybody else, use Amazon EC2 these days. But in any case, right? You know, there's a central location where the data is stored. Just like with SETI at home, there's a central server and clients that are serving the server, right? And the important difference between like Axie Infinity as a game and Second Life as a kind of quasi-game, or we could also say Decentraland is maybe a better comparison to Second Life, is that the virtual world is actually also distributed around the same network, right? So there's a Decentraland network, computers that run the Decentraland services, including managing the cryptocurrency and making the cryptocurrency and managing the blockchain, right? And so that's the difference, is the real difference between some of the historical precedents and now is the peer-to-peer nature of these networks. And as somebody who's interested in formal issues and medium-specific issues, I think that's the very important difference between centralized network versus decentralized. Centralized finance, like a bank, versus decentralized finance, like we're seeing with DeFi. The formal difference is very important. They actually do have different behaviors because of this, and different possibilities. And the law is going to mess the banking side of it up, by the way, or save us. I'm not sure which. Save us from it.
There is a comment by Tarsila. I feel living as this guy without contact with the outside world, but having a more important life online than offline. Since university became a video chat.
Yeah.
But it's better being in that desert than in São Paulo in this context. Yes.
Yeah. I don't know. I mean, the difference. What I was really trying to point to there, though, is, I mean, yeah, there are obviously similarities with telepresence and distance that are similar there. But, you know, my point about this guy in particular, who's a friend of mine, you know, with no education, right? You know, just a guy who lives in the desert and plays video games, and that's his life, is that's really what his life has become. Those of us that are in Zoom at the university and in chat, you know, there's some good chance that we're going to do things in our real life that are more than, I'm not discrediting this man for his choices, but, you know, his life, his work life is 4 hours a day as a bartender to make enough cash to live a cash existence, to live in a shack, right? I mean, he really has fallen into the matrix. And I don't know if what we're doing right now, you and I don't know if this is the same kind of falling into the matrix. I'm sure not going to talk to you for 16 hours today.
Great, Brett. I think that we have to finish here because, there will be another talk in 10 minutes.
Okay.
And it's brilliant. Thank you very much for being here. My pleasure.
Congratulations to all of you. Congratulations to all of you on Multimedia Week. It's fantastic to see this kind of initiative. PUCI's a really good university. And like I said earlier when I started, I'm really, really happy to be back, even if it's virtually. It has a place in my heart. So first place I visited in Sao Paulo, the first place I presented. So I'm really, really pleased to have been able to be with you today. Thank you.
Thank you so much. And it was a pleasure not only to see you, but your cat, Chupacabra. It was amazing.
She's a good girl. She is a good old girl.
She is.
I'm going to go give her some of her favorite renal support wet food now. It's time for her to eat.
Great.
Okay. Bye, everybody.
Okay. Bye. See you.
Gente, fazendo um pequeno aviso antes de a gente terminar a live, muitíssimo obrigado pela presença de todos que estiveram no chat, que participaram. A participação de vocês foi essencial, extremamente importante. Então, gostaria muito de agradecer por isso, mas não parem por aí, porque daqui a meia hora teremos mais um debate.
Posso falar uma coisinha rapidinho?
À vontade.
Se alguém quiser fazer alguma pergunta ainda para o Brett, pode mandar para a gente, que a gente manda para ele, tá? Eu tenho certeza que ele responderá, tá? E espero que eu não ia conseguir fazer a tradução, vocês viram que é super complicado, né? Super rápido, mas espero que vocês tenham gostado. Para mim foi um enorme prazer revê-lo e ver ele conosco aqui na PUC novamente, porque ele realmente é um professor que está sempre presente aí, sempre que ele pode, ele vem e está aqui presente conosco. Gente, até
Foi
mais.
Ótimo, Jane, muito obrigado. Pessoal, não se esqueçam de preencher o formulário que está no chat agora.
Tá bom.
E é isso, gente. A gente se vê no próximo debate. Sobre NFT ainda, debate NFT prós e contras.
Participem.
Tchau.